Alright, welcome back. Now, let's look at this question. We'll erase this question here and we'll have enough space to work with. Right, so we'll just remove this question. Tan P of x, we'll just write it down here lower. Tan P of x is equal to negative 4 over 5. Fine, so we'll have sufficient space to work here. Right, now, they are saying find two values for P of x. Well, firstly, sine P of x is 3 over 5. Let's analyze this. Because they're saying P of x, sine P of x, that means they're working in a Cartesian plane. So that means that this is sine is y over r. So it's y over r. Now, y is positive. Now, if you see that, if I draw the Cartesian plane, and there's y, it is 3. So, and there's y is 3. So, it could be in this quadrant and it could be in this quadrant. So, I'm going to draw the diagram twice. If I'm looking here and I say, well, we don't know what is x, but we know y is 3. We know y is 3. We don't know what is x. This, we don't know what it is. And that's p. So there's P of x. We know the y is 3. Now we know the radius is 5. This time we know the radius. This is the radius. Now we know the radius is 5. So there's the x value missing. So it could be this diagram. But it could also be in this diagram. Because y is 3 here. So we don't know what is the x here. So there's p here. This is also y is 3. So it could be like this, P O x. So that's another diagram. Once again, it could be this one, or it could be that one. So, sine is positive. It could be in this quadrant, it could be in that quadrant. Because the 3 is positive, y is positive. So it's positive on this side, it's also positive on this side. So, now, the number that is missing is x. So we're trying to find x. So what we do, we use the same formula. We're trying to find x. So we say x squared plus y squared is equal to r squared. We're using theorem of Pythagoras. We don't know x, so we leave it like that, x squared. But we know y. Y is 3 squared. We know r is 5 squared. So x squared is equal to 5 squared minus 3 squared. X squared is equal to, you put that in the calculator, 5 squared minus 3 squared, you'll end up with 16. So x is equal to square root of 16, x is equal to 4. I don't know what this is for number 2. So x is 4 for this question. Now we know what x is. We have found the answer, x is 4. So you got your x, you got your y, you got your r. They said find a value for cos. So cos x, now cos P of x is equal to x over r. We just found x is 4 and r is 5. So that was the answer, the first answer. We'll call it 1.1. Alright, now we go to the next diagram. Now in this diagram, we are looking at this diagram. Again, we know the y is 3, but we don't know the x. We want to find the x. So we say x squared plus y squared is equal to r squared. We don't know what is x. X squared plus 3 squared is equal to 5 squared. X squared is equal to 5 squared minus 3 squared. It's the same working, but I'm just doing it for you. Right, so x is equal to square root of 16, which is 4. Now, remember, when you're finding distance, then you always just say square root of 16. Listen carefully. When you're finding distance, you just put square root of 16. But because we're dealing with a Cartesian plane, x could be plus or x could be minus. That's why we write plus minus now here. Right? Here too, we should have written plus minus. But because it's a first quadrant, it will be positive. Because it's first quadrant, we'll only take the positive answer. Right? So you can even write plus minus 4 here, but you'll choose the 4, the positive one, because it's first quadrant. Now here you end up with the answer plus minus 4. Because it is a second quadrant, you will have to choose the answer minus 4. So this is minus 4. You see? Right? So remember, when you're dealing with a Cartesian plane and you're finding the square root, always put plus minus. Always put plus minus. And then you decide whether the x is positive or negative. You decide whether the y is positive or negative. This is the second quadrant. So in the second quadrant, it'll have to be negative. And now you want the value for cos p of x. So cos p of x is equal to x over r, which will be minus 4 over 5. So that is how we get our two values for cos. So when there is no restriction, you see there's no restriction here. They're asking you for two values. You have to find the two values like this. So read the question very, very carefully. They're saying two values, then draw two diagrams and ask yourself, where is the y positive? It's positive on the top section. So it could be in the first quadrant, it could be in the second quadrant. Y is positive on that section. That's what we mean by top section. Y is positive there. Alright, so just take a few seconds, have a look at that, and then we'll move on to number 2. So let me just get across and get ready to do number 2. Now in number 2, we were told that tan p of x is equal to minus 4 over 5. So in number 2, we were told tan p of x is equal to minus 4 over 5. If that is tan, then it is actually y over x. Now, that minus sign could be on top or it could be at the bottom. So tan p of x, now you have to use your brains and say, well, tan p of x could be that, or tan p of x could be 4 over minus 5. Because that minus can be on the top, in the middle, or in the bottom. Now if it's in the middle, it's not going to help us at all. So there it's on top, but in the next, I can rewrite this and put it in the bottom. So what do I find? I find that I got two different ordered pairs. The ordered pair for that one will be, now remember, an ordered pair is always x first, y second. So what is x? X is 5. What is y? Minus 4. In this one, again x and y. What is, remember this is y over x. Why? Because this is tan. Tan is y over x. So y is 4. So the 4 will go there. X is minus 5. So you can see now that that's in a different quadrant, that's in a different quadrant. So if I take the first one and draw it here, then you'll get negative, x is positive, y is negative. X is positive and y is negative, so it will be here. 5 minus 4. That's your x, that's your y. And that's your angle, and that's P. Right. So, you got x and y. So what's missing? R. So you're trying to find R. R squared is equal to x squared plus y squared, which will give you 5 squared plus negative 4 all squared. 5 squared 25, 4 squared 16 will give you 41. R is equal to square root 41. So you found R here. R is equal to square root 41. Now what did they say? They said find, in this question they said find I just want to try and find the question. I forget what the question was. Let's say find two values for sine x. Tan POX, find two values for sine x. Two values for sine x. Sorry, I forgot what the question was. So we're trying to find two values for sine x. Tan x is that. Find two values for sine x. Now, so we can find the first value. Sine POX is equal to y over r. Now y is negative 4 and r is root 41. Okay, that was the first case. So we're going to call this 2.1. Now we'll do 2.2. Now in 2.2, you can see the x is negative, the y is positive. So you're going to draw your Cartesian plane. X is negative, y is positive. X is negative, y is positive is here. So that's your y, that's your x. That's minus 5, that's 4. X is negative, y is positive. So the point is somewhere here. So that is P. So the angle goes from there to there. So this is negative 5, 4, this is x, this is y. Right, that's x, that's y. We don't know what is r. We don't know what is r. We don't know what is r. So we have to find r. So we'll do our working. R squared is equal to x squared plus y squared. X squared will be minus 5 squared plus y squared will be 4 squared. And you put that in the calculator, you'll end up with 41. So r is equal to square root 41. Now you want the value for sine POX. Sine POX is equal to, sine is equal to y over r. So what is y? Y is 4 over root 41. R is root 41. Alright, so that's how you found your two different answers. So these are called working in reverse. So you'll have to be a little smart. You'll have to slow down a little bit, think about the different possibilities and work them out accordingly. You see, that one was actually in the fourth quadrant. This one is actually in the second quadrant. So take your time and work it out like that. Alright. So remember, most of the time there is two possibilities unless there is a restriction. So here there was no restriction, therefore there's always two possibilities. Okay, we're going to stop there, and in our next lesson we're going to do some pattern finding. In other words, we're going to find in which quadrant the ratios are positive in the different quadrants. Which ratios are positive in the different quadrants. That will be our next lesson. Alright, thank you very much, and with that we come to the end of exercise 3.